Okay, good morning everyone. I am Sandeep Gupta. As I am told, I am going to introduce about the Arduino Mega Board. This is a Mega Board which is used for research purpose. Whenever we do research, we try to make our system so that in the implementation part, so that we can show our results in real-time process. For making this, we are going to do some experiments on Arduino Mega Board with ZigBee devices, with wireless camera, and also with the simulating purpose. I start from the session. In the present session, we will introduce you three modules. I basically divide this into three modules. The module number first, we will introduce the Arduino communication with the ZigBee and with the MATLAB also. In the module number two, we will see that how we do the MATLAB interfacing with the IP webcam to your Arduino board. That means whenever we do the research in the image processing or robotics vision, we try to make an image, so that we try to capture an image and we extract some information from that. We can extract the colors, we can extract the pattern, we can extract any type of pattern, so that we can do some analysis or we can do some type of research work. So for that purpose, we need a wireless camera, or we can also connect your laptop camera or simple webcam. So for this purpose, we have designed this module. In the module number 3, whenever we design some logics on the simulating, so that we can implement our logic, so that like your MPPT algorithms, like your some DSP algorithms, like any type of robotic control theorem, PID controllers. So we need simulating diagrams, simulating environment. Generally, researchers are basically works in two types of MATLAB platform. Sometimes we work on coding and sometimes we work on simulating, and sometimes we work on both platform, MATLAB and simulating also. So in this module number 3, we will see that how we can use our simulating diagram to connect our Arduino board, so that we can do some real-time processing. Now I will start from module number 1. In module number 1, we will talk about Arduino and ZigBee devices. For that purpose, first of all, we will see that how we understand our Arduino board. In the last lectures, you may have some knowledge about the Arduino Uno board, but in present, we will see that how Arduino Mega board is much better than your Uno board. In the present slide, you are seeing that how the Arduino board is just advanced version of your Uno board. In the present, we see that in the red rectangle box, we have a Uno board. Like your Uno board, we have 13 digital input pins, 1 RX, 0 TX, 1, and we have some analog inputs, and we have some power options like 2 ground, 1 3.3 volt, and 1 5 volt. At the same time, in the Arduino Mega board, we have some extra features. In the yellow block, you are watching that there is some extra pins which are included in Arduino Mega board, and in the your left and right hand side, you can see that there is a difference between Mega and Uno board. In the Mega, we have 54 digital input pins, whereas in Uno board, we have only 14 digital pins. Whenever we require a number of pins which are basically used in multi-level inverters or some type of applications where a large number of pins are required, so we use this simple Mega board. It is just a just advanced version of Uno, and near about twice cost of your Uno board. We can see there are 14 digital we can have 14 PWM pulses. Whenever we design some power electronic device, basically we work on PWM concept. So for designing PWM, we need some PWM outputs. So we have 14 inbuilt PWM. We were explaining about the Arduino IDE, and we have done this one. I was talking about the examples in your Arduino development board. We have a lots of examples in the Arduino examples folder. Just like you want to connect your digital input outputs, if you want to connect your analog inputs, you want to do some serial communication, and even you have some sensors like your accelerometer, your current sensor, your servo motor, stepper motor, DC motor, everything is just in this example folder. So whenever we start our IDE and we want to connect your Arduino board, and I have an Arduino board like your Arduino Mega board. This one is your Arduino Mega board, and if we want to connect this with our system, then we have to do some steps like we will collect on tools and we will click on board. There are lots of board available which are inbuilt in this Arduino IDE. Let's for example, we have Arduino Uno and Arduino Mega, Arduino Leopard, Arduino Nano. Whatever board you want to connect, you have just to click on that and you will be just connected. In the present case, if we connect on Arduino Mega, it will just behave like your Arduino Mega programming. After that, in the second step, we will go for tools and we will connect your serial port. To check the serial port, what is the serial port, where it is connected, we can use the device manager, and there you will see in your port symbol that there is some connected device. There will be written like Arduino Mega is connected, and it will be some COM port assigned. Whenever you connect your Arduino board to your system, it will assign a port to your Arduino board, and every time it will connect your system with your some COM port. So please remind, you have to connect with your COM port. So select the serial port in your COM port. After that, you will see there is a simple sketch folder where we write our program. We write our program in your void loop and we put our configuration in the void setup. In the void setup, basically we define that how we are going to use our analog pins or digital pins. Whatever we are, if we are going to use serial, then we have to put here serial.begin command. In the case of your making your input or output pins, we have to define with the help of pin mode. If we define pin mode as 13 as digital high, and it will behave like your high input. And if we put pin mode 13 as low, it will behave like your low input. So in the second loop, in the void loop, we put our program which is run in the continuous mode, because whenever we do embedded programming, we write our program in the while loop. It will again and again repeat itself. So we write our code in the void loop segment. Next, after that, whenever we have connected our Arduino board, we will just put our Blink program in that board, and it will just behave like your connection is established. In the second part, we are going to see that how ZigBee modules, what are the ZigBee modules, and how we will use the ZigBee modules. There are different types of ZigBee modules available in market, and we have some ZigBee modules in the present slide. As you are seeing that we have a frequency, different frequency. In the second column, we have a different frequencies like 2.4 gigahertz, 900 megahertz. So whatever you will purchase a ZigBee board, you will get the different versions. In the present, I have a ZigBee S1 module, and you see it is a ZigBee module, this one, and we can disconnect also like this. And we have an adapter board. For communicating the ZigBee device, we have to use some adapter board so that we can do some programming tasks. After that, we will see that what is a ZigBee module. Basically, we work on the transmission and receiving type of data transmission or analog commands or digital commands. So this board is basically used for sending your digital commands as well as your analog commands. In the range of this ZigBee module, we can see there is a maximum range of near about 3 km, and we can do different types of ZigBee modules to do different type of range. We can get 100 meter, 200 meter, 300 meter, up to 3 km. Whenever we require to control our quadcopter, or we can say our small airplane for surveillance purpose, we can do this type of module. And for that purpose, this is very useful and easy to use. In the second slide, we will set up a ZigBee communication between the two Arduino device, because we are going to make some embedded system, or we can say some dedicated applications. So for that purpose, we will show you that how we can connect our simple port to your Arduino board, and the port will be connected to your A0 pin, that is your analog pin, and the transmission and receiver lines are connected to your ZigBee modules. Here I have shown you that in this figure, we have a 3.3 volt first pin. We have to connect your 3.3 volt pin to your Arduino Mega board. There is your 3.3 supply. So please be connected. After that, we have a 2 pins, that is your TX and RX. These are the pins responsible for transmission and receiving of your data. In this ZigBee module, we can connect your system with the transmitter as a receiver also. In the ZigBee module, basically a trans-receiver type of communication device. You can use this as a transmitter, you can use this as well as a receiver also. In the present setup, we have make a connection with the port The port basically behaves like your analog input, and we can connect any type of sensor also over here. So I have used a 10 kilo ohm of port which is connected to the A0 pin. You can see over here, this one. And the ZigBee modules, we have to connect the only 4 connections. First one is your 3.3 volt supply. Last one is your ground pin, and 2 pins are RS and TS. Please make sure that the ZigBee pin number 2 is your transmission pin. So it should be connected to your receiver pin of your Arduino Mega board. And the transmitter of Mega board will be connected to the receiver of ZigBee modules. You can see over here. And the receiving end, we have the same type of connection. We will do the repeat connection. We will do the transmission connection, which is shown by blue line, to your RX pin of Arduino Mega board. The green line shows that the RX pin of ZigBee board will be connected to the TX pin of Arduino Mega board. This device can be used as a transmitter or as well as a receiver. In the next video, we will show that how it will work. Before that, I would like to explain you the program which is behind this everything. We have a simple Arduino code, which is a transmitter code. We can see that there is a serial.begin command which set up your serial communication with your system and Arduino board. Now we have used a simple command, that is your analog read pin A0. At the pin A0, it will get the analog input from a potentiometer and it will save that value into the value integer. After that, we will use the map command. What do you mean by the map command? This command is basically used for mapping the 10-bit to the 8-bit, because I have already told you that it is a 10-bit of ADC. So we get the analog input in times of 10 bits. So it is generally 1024. So we have to convert it into the 8-bit, because we are just sending the value in the ASCII format. So we have to convert it into the 8-bit value. So I have taken a second variable, that is your M value, modified value, and it will map your 1024 to 255. Now for transmission, we have to send some start symbol and your end symbol, because in the transmission protocol we have a lots of words which are sent with the this ZigBee device. So we have to make our input with some start and end symbol. For that purpose, I have used these two symbols. Between this, the value will be transmitted, and we have put some delay so that we can see it on your serial monitor, which is inbuilt in your Arduino Mega board. At the receiver side, we have to write some program so that we can receive the data by the this ZigBee device. We have to use some variables like started, ended. I will explain in the next that how we will use it. Incoming byte, message. In the void setup, again we have put serial.begin, and we have taken an LED like for output pin. In the code of receiver, how we will use it? You will use your serial.available command. For that, if any data is coming, then this loop will behave and this loop will work. You will get the incoming byte value which is coming from serial.read. In the serial.read command, the value will be read by this incoming byte. The value will be stored. For the receiving, we can see the program that in the incoming byte, if it is this symbol, this is your start symbol which I have put in your transmission program. So if the incoming bit is this, then it means that the data is coming which is your valuable for you. Now we will put the started as true. That means we are going to get your value. We will put your index at 0 in the first array in the message 0, and it will put your 0. After that, if else, it will start putting your values in your index folder. After that, if there is a incoming byte, this symbol, then it means that the data has been ended. So between these two values, we can store our data. It will this loop will break whenever we get this symbol, the AND symbol. This is the main logic. We get the incoming byte in our message array, message 0, 1, and 2. We will get 3 values, as we want to send the values between 0 to 255. So we need 3 characters. So we will use message 0, 1, and 2. Before whenever the index is less than 4, the program will terminate. Okay. So we will receive three values for three inputs, like three values, like 255 maximum value. If there is 1 that means the program has been taken start and end value, and between three values the program should end. And if it is 1 both are trues, then we will convert our A to I message. That means we will convert our value array to integer value. The message whatever is in this array, we will convert to array to integer. We will get the value in value. After that, we can write the same value to your LED pin. The LED pin, that means you will get that if you send a 255, the intensity of LED will be full high. And if you receive the 127, that it means your intensity of light will be just half. So we can check that we are getting the same value or not by the potentiometer. In the serial print command, the value will be seen in your serial monitor. This is only for debugging, so that we can we can check that the value is receiving correctly or not. After that, we will put index 0, message 0, and start it and end it. This is all about your receiver program. Now I will show a video which will tell you that how we do this one. In this video, we can see that how we transmit our data. You can see we are going to select our board and port, and the program which is written is your transmitter side program. And here we are going to see that we are getting some value which is input from potentiometer, like we have getting 3, 4, 5. And in the setup we can see there is a ZigBee modules and there is a potentiometer, and we change the potentiometer value like this. And there is your Arduino Mega board. You can see the value has been changed like this. So we can get the different values on the serial monitor in the debugging process. Now we will see that how we transmit this value to the other ZigBee device. In the receiver side, we have the same configuration which I have shown you in the earlier PPT, and we are getting the value on the same serial monitor in the second laptop. We can see there is written as a receiver program, receiver board, receiver code, and we have selected the same process board and the port. In the serial monitor window, we can see the value is coming from your transmitter side. We can see it is a value like 24, 26, which is coming from your ZigBee device. So we can do this type of work. We can set up our work for the purpose of communication. Generally, if we want to send our signal, analog signal from device, from the remote area, we can receive it your Arduino board, like your simple experiment. So for hardware validation, what we do, we try to set up a system so that we can do our research. In the first program, you have seen that the Arduino board can be used for real-time application. Now, in the second PPT, in the second video, I will show you that if you want to communicate 3 potentiometer, then you can do the same thing with the same program, and you will use a single ZigBee to communicate between the 3 potentiometer values to your Arduino board. Basically, this is used whenever, suppose we want to set up a system for MPPT control algorithm or some PV research work. So we need some control, we need some current, or we need some voltage, which we have to send to our destination device, destination place, because the solar panels basically are connected on roof and we cannot make our setup over there. So we have to do some communication device so that we can get some analog value of current or voltage, so that we can do some experiment, we can do some research, or we can log our data. For data logging purpose, this device also can be used. In that experiment, what I have done the 3 inputs from the potentiometer, like your sensor, any type of sensor you can use. In this type of programming, what will you use? You will send 2 characters like start and end for M0 value, and you will put your second character for second value. After that, we can see there is 3 value basically. First one, this value M0, second one is this, which is between the bracket value, and this is the third value. So we can put any type of symbol over here so that we can differentiate our 3 values. In this, we have seen that. Now on the side of receiver, what we will do, we will again do the same algorithm so that we can extract the value, extract the information. Now what will we will get? We will get three values with three start and end symbols. So if the data will start from start symbol, what you will get your start value. And if this value is coming, that means you will assign your index 1. That means index 1 and message 1 for second value, and index 2 and message 2 is for third value. So we are using this algorithm for getting three values. First value will be start from this, second value will be this, and three value will be between this. At the end, the end bit will be your last bit of your third analog value. So we will put this bracket over here. So if this receives, that means you have got all three values. In the second type of else, you will get your first value in your message array. In message 1 you will get your second value, and in message 2 you will get your third value. Again we will use the array to integer value integer command, so that we can convert our message to your particular integer value. Like this. It is very simple. It is just a modification of second program, first program. Here we will use serial print value. So to get the value, whatever we are getting from your potentiometer 1. So we will print like this. For value number 1, we write the three commands like this. This is command only for getting some space. And this is your third value. So by doing this, we can get the three values. Now we will see that how we do in practical purpose. For that, I have made a video so that you can better understand this one. This is our transmitter program, which have the three arrays and three values. Now let me stop it. Now you can see there is three value which is transmitting from this. This is your first symbol value, and this is your second value, and this is your third value between the two symbols. This is your first, this is your second, and this will be your third. And the receiving end, we will again do the same process. Now we see that how we do it. You can see this is the values which is coming from your potentiometer 1, 2, and 3. There is a Arduino module. Here we have a ZigBee device, and we have connected three potentiometers to show that how we can put three sensor values. You can see that there is a LED is blinking, which is showing that the value is transmitting through this ZigBee device. At the second end, we have a receiver like Arduino and your ZigBee device. In the second, we have a program which I have explained you right now, and this program is burning on your Arduino second board. So whenever we open our serial monitor, we will see that we will get three values. Like start is for start value. Value is my first value. It is your 49. Second one is 42, and third one is your 31. This values you are getting. So we can see that how we are getting the three different values of potentiometer 1, 2, and 3. So by this type of experiment, you can get number of values, because I have already told you that Arduino Mega board has 16 output pins. So we can get different 16 output input analog values to your second receiving end. So this is really very useful in your research whenever we want to get some values from viewers. Okay. Now we will see that how we can do this in your MATLAB programming. This is the next experiment number 3, in which we will see that how we can get your values in your MATLAB environment. Because we do research on MATLAB, so we can easily get your values, and we can store that values. We can do some analysis for that data. So for that purpose, I have made the third experiment. Before starting off the third experiment, we will see that how we communicate with your serial device to your MATLAB environment. In that purpose, you have to create a serial object like this command. This is your serial communication commands which are available in your MATLAB. So the first command is your serial command. It will create an object like S. You have to assign a COM port, which is done in your Arduino. So same COM port should be over there. After that, you will use board, a name, a symbol, and 9600. The board rate should be same for between the transmitting and receiving device. I mean to say, transmitting now is your Arduino board and receiving is your MATLAB. So we will use this command for making an object. Now fopen, this command is open your Arduino board to your MATLAB to start communicate. After that, we have a command that is your fprint. If we want to print, if we want to send value to your Arduino board, we use your fprint command. That means s comma value. Value can be anything. Whatever you will write over here, it will transmit to your s. That means you can communicate your Arduino with your MATLAB. In the next command, we have your value is equal to scanf. If you want to get a value from your Arduino, you will use your scanf command. If you want to close your serial communication, then you will use fclose. After that, delete s. This is the basic command which can be used for your communication with your Arduino device. Basically, what we are going to use, we are going to do the communication between Arduino and your MATLAB. And the ZigBee is already communicating with your Arduino. So indirectly, we are communicating with your ZigBee device. For the transmitting side, we have to, first of all, we have to set up for transmission of your ZigBee device. It is basically a same program which have written in your previous transmitter for MATLAB. This program was for transmitting your value from your Arduino to your Arduino board. This one. The difference is between that, we will read the analog read A0s. We are getting the potentiometer value in your value. But in your MATLAB, what we will use serial read. If we want to read our value, read some serial value from your Arduino board, we will use the serial read. Or if we want to write some value, we will use the serial write. In the present experiment, I am going to get the potentiometer values to your MATLAB window. That means it is a setup like that. You are going to get some voltage or current from PV panels which are installed on your roof, and you will get these values to your MATLAB window. Okay. In the receiving side, that means in your MATLAB environment, you will write a simple code like S is equal to serial COM37 board 9600. This program will be written in your MATLAB environment and you will run it. It's a simple program. We have used serial command to make a serial object. We have used fopen for opening this, and we have done I is equal to. For this time frame, we are going to get some values. Now I have used fscanf command so that we can input the values from your Arduino board, and it will be saved in your A variable. Now it will see that port value received. Whenever you will receive a value, the s print, that means it is the only print command which is used to print the value to your MATLAB window. So sprint basically is for printing, and fprint basically is for objects which we create, and it will create and will put your A value on your MATLAB screen. After that, we will end and we will close this. Now I will play a video which will be explaining about the transmission between your MATLAB and your Arduino board. In the receiving side, we have the same parameter, we have the same transmission code, and we are seeing that we are sending the value which is coming like your 888. It is a potentiometer value which is going to send by your Arduino board. This is a simple setup. In the second, we have a transmitter and receiver. Okay. Now this value is transmitting to your Arduino board, and this is your potentiometer. Now you will see there is a MATLAB window. In the MATLAB window, we can see the code which I have written on this. When I run this program, what we get, I get the potentiometer value received, which I have done with the help of sprint f command, and you will get the same value. It is, your value is coming like 8. So by this experiment, you can receive your analog value to your MATLAB window now. Whenever we do some type of work, it is very useful for us, so we can implement our projects. So it is one part of your Arduino and ZigBee communication. Here our first module is completed. Now we move on the second module, which is basically designed for image processing, or we can say your robotic vision applications. In this type of experiment, what we do, we are going to use your IP webcam, your Android phone, for making your Android phone as your wireless camera. It's very simple, and without investing some amount for purchasing your IP webcam, we can use your Android phone for like your simple wireless camera. For that purpose, we have to step number first, we have to download the IP webcam app from your Android phone. we have to turn on your mobile hotspot. After that, open your IP webcam app and select the start server. After that, what will you do? You will connect your PC with Wi-Fi enabled capability, or your laptop. Same hotspot will be connected. After that, what we will use, we will check that how we are getting our input from your wireless webcam. For that purpose, please type the 192. This IP will be same for your every type of IP webcam systems, and click on the flash and video. I will show a video that how we do this. Here you are seeing that this is your Android phone and this is your object. We are going to get this value on your MATLAB screen, or we can say before that we can just type your IP over there, and we are going to receive this value from your wireless camera. So I have selected this one. This window will appear, and on this window we have a video render and we have a audio player. We can also get some audio, but for present purpose we are working on the images. So we will click on the flash and you will see that how we get the real-time video. In this video you are seeing that we are getting the real-time video which is coming from your wireless camera and connected with your hotspot. You can see it is a running, and specialty of this one is that you no need to do any type of internet connection. We are just going to use your hotspot connection over there. Okay, fine. So this is your experiment which we can do. Next, we will say the simple algorithms which works on the image processing. In the first example, we see that how we get an image from your wireless webcam to your system. In that purpose, you have to use simple command, like you will use a command that URL. Please type this command over in your MATLAB framework and use a IM read, that is image read. A URL value which is going to get, it will get like a shoot.jpg. It will get a image, and it will be, the value will be stored in your IDE, RI. Then you will convert this RI to your image. Okay, I will play a video like how you will get it, and you can see in MATLAB environment how we get this. Here we have a 3-line code and we can get the value which is coming from wireless camera. And you can see whenever you run this code, you will get a figure 1 window, and you will see the picture which is sent by the URL Wi-Fi camera. It is on your MATLAB window. In the second experiment, what we see, we will use the video for our purpose. If we want to make a runtime of video, we can use these simple commands. Like the 3 commands are previous commands, and we are going to make the pictures which are getting to your video. For that purpose, you will use these 3 commands. It will be infinite loop, and you will whatever you are getting in your RI, you will just put the set fh, c data, RI and draw now. And by using this, you can get the video from your wireless camera. Okay, I will play a video which will show you that how we use it. In this video, you are going to see that how this is the line code which I have shown you right now, and you can see this is your video which is coming from your wireless webcam. You can see it is a running, it is not a still image. I am just moving it, and it is just your runtime video. So this experiment is used for getting a video from your wireless camera. It's a simple experiment. Now we come to some more stuff, like how we check our image. Suppose we have a red object in your image, so how we extract that red object? Because we do image processing, we take some red object, or we can also do some pattern recognition or character recognition. That is simple algorithm of image processing. You can go through about image processing toolbox, whatever you are going to use. But right now I am telling you that how we can use this with the help of your webcam. So I have written a simple code for getting your red image. The one thing which is you need to know if you are beginner, then it's a simple command. You have to you have to write this algorithm, and please be concentrated on this black portion. If in the IM subtract command there is a 1, if it is a 1, you will get your red component. You will stack the you will detect the red. If you put it over 2, then you will get the green object. If you put 3, you will get the blue object. Basically there are 3 prime colors RGB. So in any image we can get red, green or blue by the simple putting 1 2 3. There is some other techniques which you can also get the yellow, brown or black or white, whatever color you want to get. There is some basic other algorithm, but for basic we will use our 1 for getting a red object. After that you have to put your threshold value over here so that you can easily extract your image. For experiment purpose, I have written 0.18 for red color and 0.05 for green and 0.15 for blue. Please put it and try it yourself. It is very easy. After that, what I am going to do, if you are getting a red color, if you have easily detect the red color, what we will do, we will use sprint command so to print the value on your MATLAB screen. After that, a beep sound will be there, and you will see that a beep is coming if there is a red object in your image. Else it will show that not beeping. That means red object is not in your video. Okay, now I will play a video in which you can see that how we extract the red object. You can see there is no object in the video framework. We are going to run the same code, and after that you can see if we run this code, what we will see, this one. There is no red object in the object. What you will get not beeping. That means there is no red object basically. And if there is any red object, what it will do, it will just beep sound will be there. Now you can listen, and this is beeping. That means you have detect a red color in your video framework. If you put aside your red color, you will see there is no beep sound. Okay, so this is your basic example in which we can do experiments for red, for green, for white. You can again see if you put a red object, it will behave like you're beeping your object. Fine. So with the help of this simple experiment, we can start our research on image processing. Now we will go that how we can use this algorithm for making some real-time applications. For that purpose, we have to connect our Arduino board over this. Suppose I have a simple experiment that we want to check a red object in the image, and we want to do some application like a robotic arm will move if it get a red color. It will pick the red. It can pick a red color ball, blue color ball, or yellow color ball. For that purpose, we have to connect our Arduino board over there. In this type of experiment, we are going to mix the image processing with your real-time system. Basically, it is for implementation purpose. Whenever we implement our algorithms on mobile robotics, for autonomous robotics, or we can say a robotic arm which is far placed to you, you can do the ZigBee communication with Arduino and MATLAB in the same which I have told you earlier. And right now, if you getting an image from that, now you can extract the image, red color over there or not, or any type of color or any type of character is over there. Your Arduino will work and your arm will move like this. So we are just connecting everything to your implementation part. For that purpose, I have a simple example for that. You can see in this area, everything is just like your previous, and in this area what we see, we just put your fprint command over there. If there is a red color in your image, what you will put fprintf. That means you are sending a value to your Arduino board. That is 100 value. 100 is for red object. If it is not a red object, you will send some other value. It will be 101. Sorry, it is some mistake on over here. It should be 101. So I will show you by practical example, and this window will show you there is no red object, and in the Arduino board there is no LED is blinking. Okay, LED is 30 number off. Now we have this code, and we can see this code is written I can show you that the s.serial is used for again for making the serial object. fopen is used for open your Arduino board. URL for making your IP webcam to enabling in your MATLAB environment. The same 3 commands, and we are getting some video. It is just previous. Now after that we do the algorithm for getting some red component. We use the same algorithm, and in the next if else statement we have get that bw1 is your parameter which is getting some red object, counting red objects in your image. So if bw1 is more than 1, that means if there are more than 1 of red objects in your image, what it will do, it will print a beeping command and it will beep. The Arduino the MATLAB will beep a sound. In the fprint command we will send 100, and in the if red object is not there, it will send your 101. That means you will see that how we can send this value to your Arduino board. Now we will do some experiment like this. If we run this program, what you will see, now the program is running, it is busy, and now there is no red object in your image. So what we are getting not beeping, and LED is just off. This LED is for transmitting, it is not for bugging purpose, it is just for transmitting. No red object over there. If I put a red object in an image, what you will get, you will get this value from your Arduino webcam, and it will transmit to your system, your MATLAB window. Now beep sound is coming, that means your MATLAB is getting it, and now you can see the LED is turned on. Now this simple example show you that how you can send your command according to your image processing. If you recognize a character, you can send that value to your Arduino board. You can do different type of application. You can perform on different applications. Again, we can see it is beeping. For checking it correctly, we will remove this object from the image, and we will see that it is beep or not. At the time I remove this object, you will see there is no beep sound and LED is off. Okay. That means you are going to use this type of experiment or this type of application for making some image processing in real time. Do some hardware things which can be used for implementation part. So this was the Arduino with MATLAB, and we are going to move some MATLAB with your Simulink so that we can understand that how we can do the Arduino with your Simulink environment. Okay. Okay, it is visible now. Okay, now you can see there is a Arduino IO package which is available on your MATLAB MathWorks website. You can just download it and you can do some experiment with your Arduino board. For that purpose, you will get a Arduino IO package folder. What will you will use your Simulink block, and there will be a library which is used for Arduino. This one is the library Arduino IDE.mdl. When you will click on this library, you will see there is a lots of blocks which are available on this library. This library can be used for real-time programming of your Arduino board. There is some predefined blocks which are available in this. If I open the blink example, you will see that we can blink our Arduino board to your we can blink the program with the help blink the Arduino LED with your MATLAB window. Fine. You can see there is a 2 setup blocks. In the first setup, we have a Arduino and it is COM37. You have to change your COM port whatever your COM is selected for your Arduino board, and it is for speed 1. If you run this program, what you will get? You will get a 1010 or blinking LED in your pin number 13. Okay, so this is the simple IO blocks. We have a digital, we have some examples over there. We have a servo motor example like this. Okay, now I will show you a video which will show you the physical implementation of this type of blocks or this type of programming. In the first video, so you can see this video. For that purpose, you have to first download IDE-IO in your Arduino Mega board for communicating the purpose, for making the library compatible, Simulink compatible with your Arduino board. Once you have done is, that is your IDE-IOS folder. It will be in your Simulink block. So if you do this one and you do the programming, and if you open the library, there is some library over there, and we are going to see the simple LED blinking program. So this program is there. You can see we have changed our COM port. After that, what you will see, the LED is blinking. Now we are running your Arduino board with your Simulink block. So we can do the experiment, we can do some implementation on your Simulink. Whatever you do on your Simulink environment, you can directly send your command to your Arduino board. This first example show like this. Okay, in the second video, I will show you that how we can control our robot with your Simulink diagram. So this is a simple robotic arm which have a 2 degree of freedom. It can grip or it can move up and down. So I'm going to use a second example of your servo program. Here I will slide with the help of this slider gain. I will change the value and this servo arm will rotate. Okay, I am just putting the sliding down and you can see the servo motor is working. So for that purpose, for Arduino, for a robotic application, you can use it. You can control easily with the help of this simple slider gain. Now in the second, if you open the second slider gain, I can control the gripper command. Now this a robotic arm just gripping your object, and now again I have do the second servo motor that is just upping, which are just pulling up this object. So I am just controlling this everything with the help of your Simulink. Okay, so now you can see that this type of application can be made with the help of this Simulink diagram. We in the power electronics, what we do some on your real-time application. So whatever algorithm which you are going to implement it on Simulink, you can put over this diagram, or we can design on your this system, and we can do different type of things. So this is your very valuable for you. For making any type of electronics device, we use some this type of experiments. So this is your robotic experiment which is going to use in your Simulink environment. And for that purpose, if we want to do some inverter applications, for that we will do the PWM pulses or different type of pulses. We will make a diagram in this window and we will send with the help of some digital input output pins or PWM pins. So we can use optocoupler, MOSFET driver ICs, whatever you do on your Simulink platform, you can easily connect. Just do these two blocks on this Arduino platform and use your Arduino digital pins for real-time applications. Okay, fine. So this is very useful for your engineering research, and for implementation purpose, you can easily do it. And if you want to make a standalone application with the help of the Simulink, there is a Simulink package also available on the internet, on the MATLAB website. So over from that, you can just download it, and you can burn the program with the help of your Simulink environment. So it will behave like your embedded system or standalone system. Or okay, now it's all about some modules which I have explained, all three modules, and you can send me an email if you want to have any doubt or regarding this. I can provide you the package, I can provide you all information, I can share the slides which I have shown you, the programs, the video, whatever you want to use in your research. So please write down this mail ID and you can mail me anytime, and I will be just responding you for the purpose. Okay, and this is all about for present course, and thank you very much. If you have any question, then it is open for now.